In this video, I'm going to be going through the process that I used to create our tuning fork-based shear force sensors. We buy these quartz oscillators from TGK or Mauser, and they come with a metallic can on the outside. So to use these as a shear force sensor, we first need to remove that metallic can. We have a specific tool we utilize to do this, and the placement of the tuning fork in the jaws of this tool is pretty important. You want to leave about a millimeter from the bottom of the can to where the rollers are. That's just so that the cut happens at the appropriate point. So you can see tuning fork has just a little bit of the outer can remaining. We put these tuning forks in a ceramic Maycore holder, and this is to electrically isolate the tuning fork. It also allows us place to mechanically attach the tuning fork to our microscope. So after the tuning fork is placed into the ceramic holder, I'm going to add a small amount of epoxy just to make sure that the whole system is well bonded together. So I first apply epoxy at the top part of the Maycore. I will often flip the tuning fork over and gently pull on the bottom sides of the leads to just make sure that the tuning fork is well seated. Of course, after doing this, I'm going to go back and add another couple drops of epoxy to the bottom sides of the electrical leads, and doing that here with this pick. Once the tuning fork and Maycore system has dried, I can transfer it over to this jig that I built. It's basically a large tripod with micrometer screws on 3 corners that allows me to adjust the alignment of the tuning fork so that the edges of the tuning fork are perpendicular with the vertical axis. Looking at this tuning fork, you can see that there is a slight discoloration in the top. There is a portion that's lighter gray and a portion that's darker gray. The lighter gray portion is actually flat, whereas the darker, rougher looking portion of these tuning fork legs actually have been ground away in the manufacturing process. We want to place the cantilever only on this nice, smooth, flat portion. So that's why I rotated the tuning fork so that I had the flat portion off to the right, which is where I have better access to it. So I've applied a small amount of epoxy onto the very end of this quartz tuning fork, and I'm going back and I'm basically removing as much of this epoxy as I can. We just want a very thin layer of epoxy. Here you can see a AFM cantilever, and I've put this back on the second positioner, and I'm manually bringing the cantilever of this AFM probe, which is basically facing upside down so that the probe itself is facing towards the lens of the camera. And I have slowly brought that cantilever downwards until the cantilever came into contact with the tuning fork and it actually broke off. So you can see that there's a small just section of this cantilever that is stuck to the quartz tuning fork. And now is the kind of tedious portion of this positioning. So it's actually sped up at 2 times the normal rate just so you don't have to watch the entire process in real time. But what I'm trying to do is I'm trying to position the actual probe of this cantilever right on the edge of the quartz. And this is so that as I'm doing an approach and I'm bringing this cantilever system near the surface, I know the exact location of the probe. And what I'm using to actually manipulate this cantilever is a small piece of etched wire that's placed on that positioner that previously held the AFM cantilever and probe. So I'm flipping the tuning fork around so I can have the best angle to work. And I'm just trying to, again, slowly position that tuning fork right so that the probe is exactly on the edge of the quartz. And there it is. I basically have it positioned where I want it. So yes, this is how I am able to position AFM cantilever on the bottom of a quartz tuning fork.